Okay, this lesson is on right triangle trig, also known, you probably learned it as sohcahtoa. Some of you might have stopped right now because you're like, oh, I get this. Please just watch it through and make sure that you really understand everything that you're supposed to understand. So basically, anytime you have a right triangle, oh, that color is awful, has to be a right triangle for this to work. Okay, anytime you have a right triangle and you're given an angle, wow, that's bad. You're given an angle to reference. So let's call this triangle ABC. And I want to talk about angle A. If I don't tell you what angle to talk about, you can't do trig. You always have to have an angle. Okay? If I want to talk about angle A, I can label the three sides of the triangle with respect to angle A by calling this side the opposite side, because it's the one that's not touching the angle. This side is the adjacent side because it's next to the angle, and you're going to say, well, this side's also next to the angle. But the side opposite the right angle is always the hypotenuse. This is in every right triangle. When you're given an angle to reference, there is an opposite side, an adjacent side, and a hypotenuse. So then we can talk about sohcahtoa, or right triangle trig. And what right triangle trig says is that the sine of an angle equals the opposite side over the hypotenuse. The cosine of an angle equals the adjacent side over the hypotenuse. And the tangent of an angle equals the opposite side over the adjacent side. Now it's really, 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 really important that you understand that there has to be an angle here. There either has to be a number that the angle's degree measure is, or a letter saying find the tangent of angle A. But tangent does not go by itself. Sine does not go by itself. There is always a number attached to it. And some people want to try to separate the tangent from the number. But this, like if you look at a calculator, this is the other thing. You should be doing this lesson with a calculator. And for this particular lesson, you want to be in degree mode. A lot of times you're going to want to be in radian mode. But if you just push the mode button on your calculator, make sure that it doesn't, see how right now the radian is black? I want to go down and arrow over and enter so that the degree is black. And that's for science and for this particular lesson in math. Once we really get into trig, you're going to want to be in radian mode. But for right now, make sure your calculator is in degree. So for instance, let's try a problem. Here's a right triangle. You have to be told that it's a right triangle or you cannot do trig. Find all the missing sides and angles. Well, hopefully you dig back into your geometry brain and you say, well, all the angles of a triangle have to add up to 180. So if this one's 90 and this one's 53.4, I can just do 180, oops, let's get rid of this, 180 minus 90 minus 53.4. $36.6. So this angle measure right here is 36.6. Now I have to find side BC and side AC. Since we have two angle measures, it doesn't matter which one we pick to find these sides. When we first started, before we figured out what angle B was, all we had was angle A, and the sides we were looking to find are the opposite and the adjacent, but we're given the hypotenuse. So there's a lot of ways I could find side BC. I'm going to show you all of them, so hopefully you understand. In reference to angle A, side BC is the opposite side. So it would be the opposite over the hypotenuse. So I would say the sine of 53.4 equals x. That's what I'm looking for. I called it O. I should have called it x over 4. Now, this is just a cross multiplication problem. Sine of 53.4 is just a number. I want to get rid of this 4 on the bottom to get x by itself. So I'm going to multiply 4 by both sides. Those will cancel out. I'll get x on the right, and on the left hand side all I have to do is type in the calculator 4 sine 53.4. And I find that side BC is 3.2 units long. Now, I also could have found BC by using the cosine of this angle. Remember, I know this angle is 36.6. BC is the adjacent side. 4 is the hypotenuse. Cosine of 36.6 is adjacent, which is x, over hypotenuse, which is 4. If you multiply both sides by 4 again, these 4's cancel out, and you have 4 cosine 36.6. Watch what happens when I do 4 cosine 36.6. Same exact answer. So that means this side is 3.2 no matter how I choose to find it. The only thing you can't ever do is sine, cosine, or tangent of 90. And that should make sense to you because the opposite side of 90 is the same as the hypotenuse, and that doesn't work. You can never find sine, cosine, or tangent of this angle. You can only do it for the acute angles. So now I know that side BC is 3.2. Now some people might want to go to Pythagorean theorem right now to find the other missing side. Hopefully you realize the problem with that is that this is a rounded approximation of this side value. Remember, I really got 3.2112699. So we shouldn't use Pythagorean theorem because then you're just squaring something that you've already rounded, and that's not accurate. So we're going to find this side. I'll call it y. And I can either use cosine of 53.4 equals y over 4, y over 4, adjacent over hypotenuse, or I could say sine of 36.6 equals y over 4, because again, sine of this angle is opposite over hypotenuse. And notice, cosine has a number with it, sine has a number with it. There's also two more that I could use now that I know what one of the sides is. I could use the tangent of 53.4 equals opposite over adjacent, 3.2 over y. Or I could say the tangent of 36.6 equals opposite over adjacent. All of these 4 problems will give me the same answer. And this is a good way of showing you where if you notice in each of these 3, this one, and this one, the y is in the numerator. That's really easy when that happens, because then you just do the denominator times the other side. You just cross multiply. So 4 cosine 53.4, 4 sine of 36.6, 3.2 sine of 36.6, tangent of 36. Those will all give me the same answer. Let's do 3.2 tangent 36.6. 2.37 is what that says this side is. Let's just check it by typing this one in. 4 cosine 53.4. 4 cosine 53.4. Yep, 2.38, same thing. This was 2.376, which is 2.38. This is 2.384. Same exact thing. So, whenever the number is in the bottom and the variable's in the top, you just cross multiply. It gets a little trickier when you're down here, when the variable's in the denominator. What you do there is technically you cross multiply, so I would have y tan 53.4 equals 3.2, and then divide by the tangent of 53.4. Now this is where people just want to divide by 53.4 or just want to divide by tangent. This is just a number. It has to stay together. So when I divide both sides, see how it ends up that the y and the tangent 53.4 really just changed places? I started with the y down here and the tangent 53.4. When I did all that algebra, they ended up just switching places. So there's 2 things to memorize. When the variable's in the top, it's super easy. Just cross multiply that number times that number. When the variable's in the bottom, they switch places. So if I do 3.2 divided by tangent of 53.4, I'm going to get the same answer. $2.38. So they're all 2.38. Okay? That's that. So see if you can, well, this is different now too. So we talked about when the variable, let's say we have cosine of A. I'll show you what I mean. So right now I would do Pythagorean theorem to find this missing side because I'm given two exact side lengths and this one is the hypotenuse. So I would do 9 squared equals 6 squared plus b squared. This is another important thing to mention. Whenever you're given a triangle like this, the side opposite the capital letter is the lowercase letter. So we would call this side AC if we wanted to use two letters, or we could just call it side lowercase b. So in this case I would do 81 minus 36 equals b squared. So 81 minus 36, oops, this calculator's testy today. 45, and then I would have to take the square root of 45. So this side is the square root of 45, which is approximately 6.5 or something. Second square root. 6.7. There was another way. I could have done this without Pythagorean theorem, and let's see how I would have done that. Let's start with angle B. If I want to talk about angle B, which side is 6? Opposite, adjacent, or hypotenuse? Well, hopefully you say it's adjacent, because 9 is hypotenuse. So if I have adjacent and hypotenuse, which function uses adjacent and hypotenuse? Cosine. So the cosine of angle B equals 6 over 9. Now this is the third scenario. So we talked about when you have the variable in the top. We talked about when you have the variable in the bottom. The third place the variable can be, and the final place the variable can be, is next to the word sine, cosine, or tangent. When that happens, what you want to tell the calculator is, calculator, please tell me which angle has a cosine of 6 over 9. So to do that, see this blue cosine -1? When you push second cosine, you're saying, calculator, please tell me what angle has a cosine of, and then whatever you put in the parentheses is what the cosine is. So in this case it would be 6 divided by 9. So that angle is 48.18. See if I rounded right. Oh, 19. I always forget to look. Okay. So now I can find angle A by subtracting 90 and 48.19 from 180. But we're going to do trig, because that's more fun. From angle A, I have all three sides, but this side I got on my own. These two sides I was given. I always like to use the sides I was given, just in case I might have made a mistake. So if this is angle A, what side is this? Opposite, and this side is hypotenuse. Opposite and hypotenuse are sine. Sine of angle A equals 6 over 9. So again, since the variable is here, I have to use second. So I'm going to do second sine 6 over 9. Enter. 41.81. 41.81. If you notice, if you add those two together, you get 90 plus 90 is 180. So when it says find all missing sides and angles, that's how you go about it. Let's do a couple more problems. A 20-foot ladder leaning against a vertical wall. So let's draw a picture. Here's a 20-foot ladder leaning against a vertical wall, reaches to a height of 16 feet. So from the ground up to here is 16. Find the sine, cosine, and tangent of the angle the ladder makes with the ground. That's this angle. It could have said the angle the ladder makes with the building. That would have been this angle, but it didn't. It said this one. So which sides are we given? We're given opposite and hypotenuse. What function uses opposite and hypotenuse? Well, that would be sine. Sine of the angle, which we don't know what it is, equals 16 over 20. Let's find what the angle is. So remember, when the variable is here, ooh, edit undo. Is it going to let me undo that nasty? Yeah. When the angle is Ugh. In next to the word, when the angle's here, you have to use the second function. So we're going to go second sine 16 divided by 20. That angle measures 53.13. But it didn't even ask me to find the angle. It just said find the sine, cosine, and tangent of the angle. So the sine of the angle is this. The cosine of the angle, well, that's a little different. Now I either have to use Pythagorean theorem to find the missing side length, or I can use the angle that I just found and use tangent. But I'm going to use Pythagorean theorem because, again, I like to use the exact values I'm given rather than the rounded value that I just found. So 20 squared equals 16 squared plus x squared. So 400 minus that. This is a 3, 4, 5. I know that x is going to come out to be 15. 3 times 5, 4 times, no, 12, sorry. And I'll tell you real quick how I did that because it is useful if you ever want to go into math again. There are certain triples of numbers that are, when you use them in a triangle, they always form a right triangle. For instance, if you have triangle sides of length 3, 4, and 5, when you do a squared plus b squared, that equals c squared. That's called a Pythagorean triple. Any triangle with side lengths that are multiples of 3, 4, and 5 are always going to form a right triangle. So I noticed that 16 was 4 times 4, and 20 was 5 times 4, so the other side must have been 3 times 4. It's called a Pythagorean triple. It's really, really useful, and it's helpful in finding missing sides of triangles. So now what's the cosine of angle x? Remember, I don't necessarily need to know what angle x is to find the cosine of it. The cosine of angle x is simply the adjacent over the hypotenuse side, 12 over 20. And the tangent of angle x, opposite over adjacent, 16 over 12. Ideally, I would like you to reduce all of these fractions or turn them into decimals, but as long as you understand that this is the answer to the question, we're good. The bed of a truck is 5 feet above the ground. The driver of the truck uses a ramp 13 feet long to load and unload the truck. So, here's the bed of the truck. Here's the ramp. Find the angle that the ramp makes with the ground. Oh, so this is 5 because it's 5 feet above the ground. The ramp is 13 feet long. Find the sine, cosine, and angle. Okay, so in addition to the 3, 4, and 5 Pythagorean triple, there is also a Pythagorean triple that's 5, 12, 13. For instance, 5 squared is 25, 12 squared is 144. When you add those together, you get 169, which is 13 squared. Yet another Pythagorean triple. So I know that this missing side is 12 because I just did the Pythagorean theorem in my head. If you have no idea what I'm talking about, fine. Use Pythagorean theorem. 13 squared equals 5 squared plus x squared, and solve it. You will see that x comes out to be 12. So, find the sine, cosine, and tangent of this angle. Well, the sine of that angle equals opposite, which is 5, over hypotenuse, which is 13. Cosine of that angle, I shouldn't say x, I should just say angle. Cosine of the angle is 12 over 13, the adjacent over the hypotenuse. And the tangent of the angle is opposite over adjacent, which is 5 over 12. From a point on the ground that's 100 feet from the base of a building, the tangent of the angle of elevation to the top of the building is 5 over 4. So the tangent of that angle x equals 5 over 4. How tall is the building? That's what I don't know. I don't care what the angle is because I know that the opposite over the adjacent side is 5 over 4 in a ratio of 5 to 4. So I would say that 5 over 4 has to equal x over 100. So how tall is the building? 500 divided by 4, which is 125. I better check that. My math's not so good right now. I think it's 125, but 125. The building is 125 feet tall. Okay, that's it. We're done. SOHCAHTOA. Sine, opposite over hypotenuse. You get it. I'm going to stop.